Today we will learn some more about how to take an input to a micro device, and then we will do some activity as well. Okay. So you all comfortable with Tinkercad? Are you all comfortable with the Tinkercad or any issues with Tinkercad? Guys, can you all log into Tinkercad?
Yes, sir.
Okay. Then I'll stop my video, and can you all see my screen? Are we all good?
Yes, sir.
Okay, fine. Then we'll look about what is a digital and analog input. So I briefly explained it in the previous session as well. So if I go to my slide, there are two types of inputs, which is analog signals and digital signals. So as I mentioned, when we are using a digital signal, we will use two values, which is 0 and 1. But in analog signal, the values will be vary in a range. So for example, let's say switch input, that switch can be either on or off. So that will look as an analog digital input, which has two values. Let's say when the switch is open, we can say it's 0, and when switch is closed, we can say it's 1. So it's like this. So digital input appear as a switch, but when we consider analog input, it will appear as a series, a value in a range. For example, let's say I think you all can remember about the light level sensor which we used in our previous activities. So in the sensor, according to the light level, its value is varying. So it provided an analog value. So that's the difference between digital and analog inputs. So are you all clear with that? Guys, are you all clear with that?
Yes, sir.
Okay. So we will do a little activity in our last end of our session. So before that, I will do some activities to understand these digital analog inputs, and as a revision also. So I will take take an LED and a resistor and a switch and a battery. Then what I'm going to do is connect them to light up the LED. So you did the same task in your previous session as well. Let's see how we can do it. Okay, when we are using a resistor, we have to change the resistor value as well. So here there's a color code. Once you see the color code, you can understand its value. For example, I'll show you a simple resistor calculator here. So this is a simple resistor value calculator. So what you can do is once you select the color codings, for example, this has the color coding of brown, black, red. So we can use brown, black, red, and there's a gold strip as well. So then brown, black, red, gold, and you can see the value is 1 kilo ohm. So there's a specific table which is specified to calculate the resistor values. You may learn those stuff when you are learning much on electronics, but for the simple use, you can use this kind of simple calculator. And guys, as I mentioned in our previous session, once the resistance is high, it will resist to the flow of current. That means it will consume some amount of voltage, so that we have to use the optimum value for the resistor. So I will select, let's say 220. Okay. Then once I switch on, my LED turn on, and once I switch off, my LED turned off. So this is a digital, this can be considered as a digital input. So what I need is, I want to read the value from my microbit device. So that I will take my microbit device. And I will connect accordingly. So here we have a coin battery here, but because we have a 3-volt output from our microbit device, I can use the 3-volt, 3.3 volt output from this pin. So I will remove my battery, then I will connect my input. Then I will connect my ground. Okay. Then once you start the simulation, my LED is turning on, but I don't know about the signal. So I don't have any feed from feed as an input to my microbit device. So that what I can do is I can use this GPIO pins, which is general purpose input output pin. So this pin 0, 1, and 2 are available to take any input, or we can give some output from those those 3 pins. So what I will do is I will connect one of these pin to here. And I will change my circuit a little bit. Okay, now it's working. So what happened here is, once I put the switch in this position, both both of the terminals in the LED is connected to ground. So I think you can understand it, because here we have used the mirror pin as a common pin and as an input to the positive end of the LED. So once I put this slider here, my ground is connected to this pin, and it is short circuited with the common pin, and the path will go like this, and it will go to the positive end of the LED, and the negative end of the LED also connect to the ground. So there will be no voltage difference, so LED will not turn on. Once I put my slider here, and now my switch is connected to the 3.3 volt, and then this common pin and the terminal 2 is short circuited. So my common pin is connected to the positive end of the LED. So here the cathode is, or cathode or the negative end is connected to the ground, and positive end is connected to 3.3 volt. Now the LED can turn on. Can you all understand it? Or should I explain it again? Guys, are you all good with the circuit? Guys, can you all hear me?
Yes, sir.
Are you all good with the circuit? Can you understand it, how it's working?
Yes, sir.
Okay, so if you have any issue, please let me know, then we can clarify it. Okay. Now,
Yes, sir.
now you can understand that the voltage in this position can be changed from 3.3 volt to 0 volts, which means ground, once we slide the switch. So once we slide it here, it is 0 volts. Once we slide it to this position, it will be 3.3 volt. So that voltage is fed into this 0 pin. If we read the value of this pin, we can identify whether there's a voltage or not. So now I will go to my codes, and let's look how we can take the digital input. So I will use this forever block, and first I will take this if else. Then when I go to input, no, if I go there, let's check what we have. Yes, here there's a block which can read and read with the condition where when digital pin is high or low, so I can write it here. And what I'm checking here is whether my digital pin P0 is high or low. Okay. Then, so I can compare whether my digital pin is high or low. To check it, let's have some icons to be displayed. So if my pin is high, let's say there's a smiley face. And if my pin is low, let's have a sad face. And then we can run it. So when the digital output of pin 0 is high, there's a smiley face, and let's make it low. It is a sad face. So that's how the digital inputs works. So can you try it? I will give
Yes, sir.
5 minutes and you can try it, and then let's check what will happen if we read the analog value of this digital input. Okay. And guys, for those who have some experience with the simulation and with electronics, you can use the breadboard which is here. So you can use this breadboard to create the circuit. I will teach you how this breadboard works. Others, if you have any experience, you can use this breadboard. Okay. So I will give you 5 minutes. quickly create the circuit and try yourself.
Can you show the code?
Sure, I will. Okay, did someone do it?
Sir, can you show this code?
Sure.
Sir, I did it, sir.
Okay.
So can you run the program and show?
Okay, I will.
I did that, sir.
Okay. So this is how the program is working. When my slider is at this position, we are the input is connected with the ground. It shows a sad face because my digital read is low. Okay. Then when I turn it on, my digital read will be high. Now it will appear as a smiley face. Okay, did you get it?
Sir, how to turn on that?
To turn on the switch,
Yes, sir.
you just have to click it. Yeah, once I click it, it can turn on and off. This is a sliding switch, so you can check it here. There is a slide switch. So this
So
is the
the
switch.
digital pin code, digital pin block, where did you get it?
Once you go to inputs, you can slide down. Here, the condition logic will be there. This digital pin condition. Okay.
Okay,
And
sir.
this part is a if else condition. So once you go to control, there is if condition. You can take it and combine those two. Okay. Did you get it?
Yes,
Yes,
sir.
sir.
Can I show it?
Sir, can I
Okay.
show?
Okay. Let's see. You can show it.
Sir, can you see?
Yes. Okay. So can you please turn it on? Okay, nice. Okay, good.
Thank you, sir.
Others? Anyone else? Okay, nice. Okay, good. Nice. Very good.
Can you share following?
Okay, guys. Then let's do something else. So let's check what will appear if we read the digital analog input instead of digital input. So here in our code, we have directly used this block, which compare the digital pin as a digital value and check whether it's a high or low. Instead of that, what we can do is we can read the analog read from the same pin. We have providing a digital input, but let's see what will appear. Before that, I will show you what will be the numerical value appearing in when we are sliding the switch. So here, I will use show number block here, and then for the input, I will read the digital pin. So once I read the digital pin and start the simulation, once my slider is ground position, in this position, uh, it will read the ground value and it read as a 0. Then once I turn it on, it will be 1. So as I mentioned, guys, we in the digital input, we have two inputs, whether it's 0 or 1, so that this is appearing as 0 and 1. Then let's use read analog pin. And once it's in the ground position, the P0 pin is reading the voltage which is provided from the ground, which is 0. So it will be 0. Then once I turn on, that means there will be a certain voltage value here, and the analog read will read the corresponding value according to that voltage. So when you are working on electronics and learn much more, you will learn about how the process is working here. But for this moment, you can understand that it will read the voltage and show or identify it as a certain value. So this is how the analog input works. So before we are going to do some work with the analog inputs, I will show you about the breadboard. So have you seen breadboards before?
Sir, can you tell me?
Yes,
where
sir.
Yes, sir, I have.
Sir,
So-
can you tell me where you got the digital pin block?
Yes, I will show you. So once you go to the blocks, here in the input, there is a digital read pin and read analog pin. And once you go down, there's a digital pin block with the comparison as well.
Okay, sir, thank you.
Okay. So some of you have worked with the breadboard. So for others, I will show you how the connection in the breadboard lays. So here, this is a breadboard. So this is a small breadboard. And once you take a breadboard, there are certain holes. And there's a certain pattern as well. So the easiness of using a breadboard is that you don't have to solder any circuit. You can plug your devices like ICs or resistors or LEDs for this holes, and the connections will be already available in the breadboard. So guys, this is how the connection lays in a breadboard. So you can see that there is long two strips in the both side of the breadboard. So if you take the breadboard, there are two connections. These are the connections I'm talking about, and it is connected along this path. Okay, the line path. So once you plug something here, once you plug something here, it will short circuited through this path, through this entire path. And this one also has the same property. It is short circuited in this path. Here also the same. So once you put something here, it will short circuit along this path, and that's how it's working. Then the middle part, it is completely disconnected from these two paths as well as this part. And in the middle connections, the paths are short circuited as appearing in the diagram. So these holes are short circuited. So once you plug something here, you can take it out from here as well, or any pin in this column. Okay, So that's very simple to have the connections. So once you have a real breadboard and practice it, it will be a very easy thing to connect. So there's no complex logics. So that in our circuit also we will use a breadboard and see how analog input can be filled. So I will remove these things and I will use a breadboard. So here I will take a breadboard and to simulate the analog reads, I will use this potentiometer. So potentiometer device like the volume controller in your analog or simple analog radios. So once you turn this rotator here, I can turn this rotator here. Can turn this. Then there will be a voltage out from this middle pin. So I will show you how we can connect it. So first of all, I will connect my device, so my potentiometer with my breadboard. So what you can do is you can place it properly like here. So here in this part there is no the path is short circuited and this path also short circuited, but there is no short circuit with these two columns. So once you put your mouse pointer in a certain hole, it will appear what are the short circuited points. Okay, can you see it? Can you see the short circuited points?
Sir.
Okay. Then I will connect my ground here and my 3.3 volt out for this part. Because these parts are short circuited, if I get something from here, it will have the ground connection, and if I take something from this path, it will have the 3.3 volt connection. So if I go to my terminals, there is a terminal 1 and terminal 2. Now what I can do is I can connect terminal 1 with my ground and I will connect my terminal 2 with the positive voltage. So there will be a voltage difference between 0 and 3.3 volt. And the middle pin will out a voltage between this ground and 3.3 volts. So once I rotate my slider, the voltage which is emitting from this middle pin will vary. Okay. So that I can feed a varying voltage to my pin in the microbit device. So I will show you it. So I will take a connection from my middle pin and I will drag it here, and let's use pin 1. Okay. Now everything is connected as intended. Now what I can do is I can read the value from pin 1 and I will show it in my display. So I can go to my codes. I can use show number block here. Then I will read the analog pin, and it will be pin 1. And let's try it. Now it is 460. So let me slide it. So in this edge, it is directly connected with the ground. So it shows the number 0, and I can increase the value. That means it will emit more voltage from the middle pin or the wiper. And I can increase it as well. 830. And at the very end, it will be 1023. So that's how the things are working. So in the future, once you're working with the electronics, you will learn how this 1024 number is appeared. And for this stage, it is enough to know about analog inputs. And if you using a sensor, you should understand whether it is a analog sensor or digital sensor, or you should use analog input or digital input, or if you are planning to have or design some sensor, you should understand whether you are emitting a digital signal or analog signal. So it's very useful to work in our project. Okay guys, can you try this as well? I will turn on the cords and you can try this. Any questions, guys? Do you have any questions?
No, sir.
Okay, try this and then we will look at some motors as well. So I will give you 5 minutes. Quickly try this.
Sir, what do we want to make this?
Sir, I didn't get you.
Sir, do we want to make this circuit?
Yeah, you can try this and see what's happening with your circuit. You can use a potentiometer here and wire this.
Okay, sir, can I show it?
Sir, can I show?
Yes, we'll see. Okay. Okay, can you run it, please? No, the previous one. I think you have an issue with it, aren't you? Okay. Okay, good.
Thank you,
Anyone
sir.
else? Anyone else? Yeah. Can you run it?
So can I show?
Wait a second. So can you please turn your slide a little bit and show it to us? Can you slide the slider potentiometer? Okay, I think there's an issue with your circuit. So if you see your middle or the wiper, I think it should be connected with the yes, you have to connect like that. No, first delete the path and then you can connect it again. Okay. Done. No, okay, shall we play it? Can you rotate the slider? Okay. Can you show your code as well? So here you have used the pin 0 here, but you have connected to pin 1. Okay, now you can start the simulation again. And now you can slide it. And now it's working, isn't it? Okay, good. Anyone else? Nice, very good.
Sir, can you see?
Yes. Okay, good. Nice. Okay, guys.
Can I show?
Yeah. Okay, good. Then guys, so here we learned about inputs, and in our previous session we learned about an output as well. So we linked an LED, and if we go to our components, there are some motors and things like that as well. So we to these moving devices we call actuators, and let's try to work with the servo as well. So servo is a motor that we can rotate for certain degrees or certain numerical number. So I will show you that as well. So this is a servo, so actually servo motor. So if we signal it to turn certain degree, certain number of degrees, it can turn up to that position. So I will briefly show it to you because the time is limited, and you can try with the other sensors and actuators as well. So first of all, I will connect my ground and connect my power to 3.3 volt, and I will connect my signal as well to pin 0. Then once I go to code, and when I go to output, there is a code which is rotate servo pin. So let's use it and check. So I will rotate 90 degrees. Then let's check whether it is working. Yes, it's rotating 90 degrees. So I hope you know about how to estimate the degrees you have to turn. Probably you should learn those stuff in your math lessons. So I will use a simple program to rotate the server pin to turn its 90 degrees and turn back into minus 90 degrees, which is other direction. I don't know. Maybe negative values are not working with the block. Okay. So what we can do is we can use 0. So that means when we use 90 degrees, it will turn to the position which is 90 degrees, and initially it is in the position 0, and when I use this block, it should come back to its original position. So let's try it. Okay, it's 90 degrees, come back 90 degrees, and it's turning back again and again. So that's how we can play with an actuators as well. Can you all see this?
Yes, sir.
Okay, you can try this as well. Try the actuator as well. Then we will spend our next hour with an activity. And you have to do it by yourself. I will teach you and I will guide you. And you can try that as well. There will be, there are two, I can give you 2 minutes. You can quickly set up the blocks and try it. If you have any issue, you can ask.
I have done.
Sir, can I show? Sir, can you see? Sir,
So can I share the screen?
Sir, can you share the screen?
sir, can I show? Sir, you are muted.
Okay, now you can see my screen. So those who want to copy the things, you can do it quickly and show it to me.
Sir, I want to show.
Okay, you can show. Nice, very good. What about others?
Yes, sir.
Sir, can you see?
Yes. Good.
Thank you, sir.
Okay. Nice.
Sir, can I share?
Yes, you can. Okay, good. And you have put 90 degrees in the second chord as well, second block as well. So that's why it's not rotating back.
Okay.
So you can change it to 0.
Can you show the code?
Yeah, sure. Okay, good. And this is the code. Okay, guys. So hope you all did it, and then we will go to do some activity as well. So now we have learned so many applications, so many methods to take input and outputs, and we can now create some project. So shall we create some alarm? We will create an security alarm with using your microbit devices. So guys, I think you have seen this stuff. It's something common in common as an household item. So this is a security alarm where it alert when a certain motion is detected. So have you seen this? Guys, have you seen this kind of alarms, security alarms?
Yes, sir.
So we will create one by ourselves. So that we have to use a sensor and a buzzer as well. So guys, working with or knowing this concept is a very common thing. Everybody can learn those stuff, but the importance of you learning coding or using electronics or this kind of embedded systems is uh, you have to develop the skill of solving problem by yourself. So once you have a requirement, you should be able to identify or uh, decide which method should I use to solve the issue, or how I will solve this issue. So that's the skill you should develop, so that let me show you how we can do so. So it will improve with your practice. So once you take your household problems and once you try to implement any solution, then you will learn or practice how you can improve your skills. Or, or then now what we are going to do is we are going to build a security alarm system. So that we have to think that what we can use for that. So you can identify your requirement of identifying any kind of motion. So there should be a sensor which will detect the motion of a person or something, and then there should be output to alert the others. That can be a light, or typically you can see once the motion is detected, there will be a light turning on. Or you can use a sound, so that you can use something like buzzer. For this task, we will use a motion sensor, or simply we say PIR sensor. And to alert the others, we will use a device like this, which is a buzzer. So first of all, I will show you how this PIR sensor works. I will delete this stuff. And this is the PIR sensor. So you can connect it to ground. Then you can connect with power. First of all, I'll take a breadboard. I'll take a breadboard. Then I'll connect my sensor here. I'll connect ground. And my power here. I'll short circuit this pin sensor. Done. Then to power up my PIR sensor, I will connect ground and power. Okay. Then there's a signal input. I will connect it to my P0. So now if I play,
So what is that green color one on the
let's
breadboard?
see. Red color one means
Green color one
this one.
on the breadboard.
Yeah, that's the sensor we are using. Let me show you. So this is the PIR sensor which can detect the motion. Okay. Did you get it?
Okay, sir.
So it will work like this. So you can simulate it once you click on the PIR sensor. Then once you move it in the green area, the motion will be detected and a digital signal will emit from here. So let me show you. Output show number. Let's read the analog pin P0. So we will use a digital input. Okay. Let's see what will happen. So guys, assume this green dot is a pulse. So the light green area is the visible area for the sensor. So once we place the sensor in a wall or somewhere else, it has a area which it is visible to the sensor. So once someone moving from this area, you can see the sensor can detect it and it emit a certain voltage. And because we are reading the digital grade of that, it appears as a 1. So once it is not moving, there is no motion to be detected, so it will be 0. This is a motion sensor. So once the motion happen within its visible area, it is 1, and once there is no motion, it is 0. So if we go outside from the visible area, the sensor can't detect any motion. So once we are in the visible area, it can detect the motion, and once we are in the outside, it can't detect the motion, and once we still stand still in the visible area, even that also can't be detected using the PIR sensor, so it will be 0. Did you all get it, guys?
Sir, can you show the code?
So here I have used a show number and digital read digital pin. So guys, for this activity, so far you have copied my code and try it. And now what I want to do is you have to decide what is the code you are using. So that's the skill you should develop. So I can teach you the things, but the part of thinking the solution is yours. So now onwards, for this activity, I will ask you what to do, and it's your responsibility to do it. And let's try to develop our skill in programming from that way. So guys, what I want to do is I want to make a program like this. So I showed you how to use a PIR sensor, and I want you to show a smile face like this if there is no motion is detected. But if a motion detected, you have to show me a symbol like this, which is a exclamation mark. So can you do the task? Can you try it, guys?
Yes, sir.
Yes. Can you do the task? Did you get it? මම සිංහලෙනුත් කියන්න ඔයාලා කරන්න ඕනේ මේකයි. මම දැන් ඔයාලා මම දැන් කියලා දුන්නා PIR sensor එකක් වැඩ කරන හැටි. ඒකට sensor එකේ motion එකක් අපි දැන් visible area එකේ motion එකක් වෙද්දී එයා detect කරගන්නවා as a digital signal. And when we are in the outside අපි එළියට වෙලා ඉද්දී motion එකක් වෙද්දී එයාට detect කරගන්න බෑ. So we can read it as a digital output, and it will be a digital input to our microbit microbit device.
Sir,
So that yes,
sir, අපි දැන් ඔක්ක හදන්නද?
yes, you should start now,
Okay,
and
sir.
we will check it. And what you should do is instead of showing 1 and 0, once the motion is detected, you have to show me a smiley face like this, and once there is no motion, it should display once there is a motion, you should display an exclamation mark or any symbol you prefer, and once there is no motion, you have to display the smiley face. ඔයාලා motion එකක් detect කරගත්තොත් මට smiley face එකක් පෙන්වන විදිහට motion එක detect කරන්න ගත්තේ නැත්නම් මට smiley face එකක් පෙන්වන්නත් motion එකක් detect කරගත්තොත් වෙන symbol එකක් පෙන්වන්නත් මට පොඩි software එකක් දීලා පෙන්වන්න පුළුවන් නේද?
Sir, can you go to the circuit?
Yes, sure. So this is the circuit, but the code should be do by yourself. Let's have some 10 seconds, so it will be very easy. I'll show you how to do it in the previous activity as well. So what you have to do is you have to read the signal, compare it, and show the necessary signal, necessary symbol.
Done, sir.
Done, sir.
Sir, I did it.
Me too, sir.
Sir, excuse me, sir. Sir, I did it.
Okay, so you can
No, me
raise your hand once you finish it. So, and we will give some time to others as well. So when most of you have raised your hand, I will ask you to show it to me. Okay.
Okay, sir.
So once
Okay, sir.
you've done, you can raise your hand.
Sir, can you tell me where you got the show number book? Sir, your mic is muted.
In this activity, instead of show number, you have to use the symbols. And both of this show number and the show LED or show icon is available here. So you have to use them. So what you want to do is you have to show the smiley face and the exclamation mark according to whether motion is detected or not.
Okay, sir. Thank you.
Okay. For those who done the task, can you show it to me?
Can, sir.
Yes, we'll see. Okay.
Sir, can you see?
Yes. Can you start the simulation? Okay, now it's smiley face. So So can you please do some motion and let's see. Okay. Good.
Sir, can I screen share now?
Okay, you can.
Sir, can you see?
Yes. Okay, good. Anyone else? Okay, once it's moving, it's exclamation mark. Then once it's outside, smiley face. Okay, good. Okay, very good. Anyone else? Okay.
Sir, can you see?
Yes, I can see it. Can you please run it?
Okay, sir.
Okay. Yeah, I can't see the change of the screen.
Okay, sir.
I can't see that, so I will teach you how to do it. But we have to do it by yourself. Can you please show your code as well?
What, sir?
Can you please show me the code?
Sir, can I show?
Yeah. Okay. Can you please start the simulation?
Sir, I showed.
Okay.
Sir, can you see?
Okay. Can you show me your code? Okay. Pin 0 is high. It should be. I think it should be other way around. When the pin is high, it should be an exclamation mark, and when it is low, it should be the smiley face. When the motion is detected, the pin should be high, isn't it? Okay.
Can I show?
Yes. I think you have used the buzzer as well, isn't it? Okay. There's a little issue when you are using the buzzer, but it's very good. You have tried to do the next task as well. I will show you the issue you're having when using the buzzer. So there's a when you're using the buzzer, there's a block. Yeah, you should initiate the buzzer. So when you go down, there is a block which is called
Sir, we
analog.
can't see. We cannot see your screen.
Okay, wait a second. Once you go down the outputs, there is a little block called analog set pitch pin. So once you're using the buzzer, you have to initiate it. So you can put it in on start, and you can initiate the pin to use the buzzer. Okay, did you get it? Then I will show you how the task should be done. For those who didn't complete it or
Sir, can I show?
Yeah. Let's see.
Sir, can you see?
Yes. Okay.
Thank you, sir.
Then I will show you how to do it. So first of all, what we need is if talk. So I'll go to my control blocks. I'll choose this. Then I will use a math operator to compare my digital output. Then I'll use digital read pin and I read my 0th pin. Then I compare it with 1. So you can use the block I showed previously as well. This one also you can use it, but I will use this one to demonstrate the other way as well. So here what I'm going to do is I will read my digital pin and when it is 1, that means there's a motion detected. I showed you that it emit 1 when we read digital input when there's a motion. So then I will show the certain mark or certain symbol when there's a motion, and otherwise I'll show a smiley face. Okay. Then let's try it. Now it's a smiley face. Once there's a motion, there's an exclamation mark and it will turn back to smiley face when there's no motion. Okay, when I'm outside, it's smiley face. When there's motion again, there's exclamation mark. So that's how we can simply achieve the task. Then we look at what else we can do. Task 1, then it should be task 2 and 3. So now in the task 2, you have to play an alarm once if the motion is detected. So you can play the buzzer once the motion is detected. So I taught you about using the buzzer in our last session. So can you please connect the buzzer and show me how you can code it? For those who didn't complete the first task, you can copy this. Others, you can try to connect the buzzer and play an alarm once. So buzzer should be in somewhere here. Yeah, here it is. So you can connect it accordingly. Someone has tried it as well. So you have to try it by yourself. So what I want to do is once you detect a motion, there should be a sound. To play the sound, you can use these two pins. First, you have to initiate using analog set pitch pin. Then you have to use analog pitch pin, pitch block. This one, this block, and this block. So what you want to do is you have to play the pitch once you detect a motion. So if someone did it, you can raise your hand. Others, you have to try the task. So if you have any question, you can ask. But me දෙවෙනි task එකේදී වෙන්න ඕනේ ඔයාලා alarm එකක් හොද බස් එකක් connect කරලා once you detect the motion, you have to play a sound once. So that will be very easy. About the wiring, you should decide. Let's see whether you can do this. කාට හරි පුළුවන් වුණාද කරන්න? Guys, task එක තේරුණාද? Did you get it? Did you understand it?
Yes, sir.
Okay. Quickly do it. Quickly try it.
Sir, can I show?
Sure, you can show it. Okay, nice. Okay, actually, the sound is not playing well. That happened because you haven't initiated the pin. So can you please go to code? Go to your codes. Yes. Please go to the codes, code blocks. Okay. Then, yes. Instead of analog set pitch pin volume, to play the sound, you can go below and set, there's another block. Go to outputs. And instead of analog set pitch volume, you can use, yes, go below. You can use this analog pitch block instead of analog set pitch volume block. And you can set your pitch and time to play from these numerical values. No. Here in the text block box, in the block you can set the pitch and the time to play it.
Okay.
And one other thing, you have to use this initiation as well. So once I advised, you have to use this analog pitch block, and you can use numerical values to set the pitch, let's say 250, and it will play for 100 milliseconds. And before using that, you have to initiate the block as well. So you have to use analog set pitch pin, and then you have to select the pin. So now my buzzer should be connected, let's say pin 1, and I'll ground this one. Then I will set my analog set pitch pin to 1, and I will play once the motion is detected.
Sir, can't see your screen.
Okay, sorry for that. So what I did was, first I have connected my negative into ground and positive edge to pin 1. Then first I will initiate my pitch pin. So I will use this analog set pitch pin, and I will set it to 1. Then I'll use this analog pitch block, and I will play the sound. So I will use the pitch as 250, and I will play it for 100 milliseconds. Let's say 200 milliseconds. And let's try it.
Sir, can you share your code?
Yes, I can share it, but you have to do it by yourself. Then I will explain the third task as well. So those who complete the second task do the third task as well. So in the we have completed the task 1, task 2, and what you can do is, you have if alarm is detected, playing it once will not be enough. So what you have to do is, once the motion is detected, you have to play it continuously. Okay, let's say you detect someone is violating or coming into your house without permission, then you can detect the motion, and the alarm should play continuous alarm sound. Okay, then I will explain the task 5 as well. So what you have to do is play the alarm. If the motion is detected, then it should be continuously played, and once we press button A, then only it should be turned off. තේරුණාද? ඒ කියන්නේ අපි motion එකක් detect කරගත්තාම ඒක ඊට පස්සේ දිගටම alarm එක play වෙවි තියෙන්න ඕනේ. ඊට පස්සේ අපි okay then අපි හිතමු කවුරු හරි වාගේ ගෙදරට හොරෙන් ආවා. එතකොට වාගේ motion එක detect කරගන්නවා. Then the alarm should be play continuously. Then අපි හිතමු අපි දැන් හරි ආපු කෙනා හොයාගත්තා. Then we have to have a way to reset the alarm, so that once you press the A, the thing should be reset, or the alarm should be turned off. Did you get it? තේරුණාද ඒක? Guys, තේරුණාද? Can you hear me, guys?
Yes, sir.
Okay, task එක තේරුණාද? alarm එක motion
Yes,
එක
sir.
detect කරගත්තාම play වෙවි තියෙන්න ඕනේ alarm එක. Then once you press it press A, it should be reset. So can you please make a way at least can you please make it play continuously? Then we will look on how to make it reset once you press A. And I will show you the code as well. And you should try the next task as well. If you have any questions, you can ask. So the task I gave you will be little bit challenging. Actually, it's not challenging. So you have to think a little more further and do it. But that's what we are doing in engineering. So once you have a requirement, you should think a way to provide a solution. And now, instead of knowing things, providing solution is the skill that I want you to develop. So if someone developed or someone complete something, you can raise your hand. And guys, this will be our last session to complete the content. Then at the end of the session, I think Mindya will explain that we will have some competition like thing to test your skills as well. And this will be the last content we are following. Okay. So anyone did the task?
Yes.
So can you show it?
Okay.
Okay, nice. What about others? Anyone? So because time is passing, I will show you quickly a way to do the task. So the task I'm going to do is I want to play the sound continuously if a motion is detected. So that I will use a variable. So I'll create a variable which is named as detected. And at the very beginning, it will be 0. And once something is detected, it will be 1. Then I'll use a control structure which is called repeat while. So it will repeat while the condition is true. Then I can check whether the variable detected is 1 or 0. So once something is detected, it will automatically be 1, and it will be remain the same even the motion is not detected, because we haven't changed it anywhere else. At the very beginning, it will be 0, and once motion is detected, it will be 1, and in anywhere else, it won't be 0. So that I can compare it. I can go here and use a block to have a logic comparison, and I will compare my variable and check whether it is 1. So it is 1. While it is 1, this block should be repeated. So I will use a block to play the sound. And I will use a wait as well to make it appear as an alarm. Now shall we play it? So once the motion is detected, it will play continuously. Although my motion is now not detected, it won't change again. It will play continuously.
Sir, can you show your code?
Okay, this is my code.
So wait a
And
minute.
I will explain it again as well. So once you start the program, I will set my detected variable is 0 on start. Then once motion is detected, I will set my detected variable to 1. Then at the end of my forever loop, I will use another loop which is called repeat while. So that loop will repeat while its condition is true. So that I will compare whether my detected variable is 1 or not. So whether my detected variable is 1, it will look as a or condition with true, then my loop will repeat until that condition is true. So that at the inside of the loop, it will play the pitch which I have defined, and here it is a wait block to make the sound appearing more like an alarm. So once I play it, and at the very beginning there is no any alarm. So once the motion is detected, the alarm will play continuously. Did you all get it? Are we all good?
Yes, sir.
Okay. This is how the things happens. And then what I want to do is once you press A, the alarm should turn off. Okay. Now it is playing continuously, and there is no way to reset it. I want you to make a way to reset the system by pressing A. So it will be very simple. What you have to do is think a little bit and play with this variable. So can you please make it? Then මේ alarm එක continuously වදිනවනේ. මට මේක reset කරන්න ක්‍රමයක් නැහැනේ. So you have to make a way to reset it. So that will be pressing A. Once alarm එක මේ play විවිතියෙද්දි continuously play විවිතියෙද්දි ඔයා A ඔබපුවාම මේක නවතින්න ඕනේ. අන්න ඒ වගේ දෙයක් මට හදලා පෙන්නන්න. Can you try that, guys?
Yes, sir.
Okay. Try it, will you? That will be very simple. I'll give you 5 minutes.
Sir, my one is not working.
So can you please share it? Let's see what has happened. Okay, wiring is good. What about your codes? Can you show me the codes? Okay, you have set your pitch pin. In the set detected, in the set block with the detected variable, I think you should change this to 1 or like that. Yeah. Now, can you please run it? Now it's working correctly, isn't it? So then
Yes,
you
sir.
can go.
Thank you, sir.
Okay, now very good. Then you can go to next step as well. So what I want to do is your alarm should be turned off when you press A. When it is working continuously, you can press A and make it reset or stop.
Sir, can I share my screen?
Okay, guys. Then I will show you the next step as well. So this detected, once they detected this one, the alarm plays continuously. So if I change it to 0 or anything else with the press of A, now the loop will be ended. So that what I can do is I can go to my inputs, and when I press button A, I can set my variable to 0 again. Then when I try it, it's playing continuously. That means my detected variable is 1. If I press A, it will be 0, and this loop will be ended here, and it will run as usual. So it's that much simple. You can try it.
Sir, can I share the screen?
Yes, you can share. So I can't see it. Okay. Okay, now it's alarming. Okay.
Excuse me, sir.
Yes.
Can I share it now?
Okay. Can share it.
Sir, can you see?
Yes, I can see it.
Sir, can you,
Okay, alarm is playing. Can you press A and let's check what will happen?
sir, can you see the code?
Yes. Okay, good. Very good.
Thank you, sir.
Anyone else? Okay. When you press A, it turned off. Okay, good. Very good. Okay, very nice, guys. Anyone else? Okay. So all of you guys did a very good job. And as a homework, what you can do is you can send an alert using radio signal as well. So here what you can do is you can use another microbit device. Let me show you. You can use another microbit device, and you can program it separately, and you can use the previous code as well, and you can try to send a alert signal from this device to the next one as well. So you can do it as a homework. Then since it's 5 o'clock, I will end the session. So guys, this is the end of our content. So we will arrange some activity as well for you, and hope you will do some good activities with your microbit devices, and you can simulate it as well, and try different sensors, different actuators, and hope you got a good understanding about the programming and using microbit as well. And so guys, this will be the end, and shall we wind up? Okay,
Yes,
guys, then goodbye for you.
Goodbye, sir. Thank you, sir.
Goodbye,
Okay.
sir. Thank you.
Thank you, sir.
Thank you, sir. Goodbye, sir.
Thank you, sir.
Okay, welcome. And Mindya, is there something to share with them?
So I would like to thank Jalia sir for conducting the session for a long time.
Welcome, Mindya. And what about the competition?
So we will be holding a competition to check whether you learn something from this session or not. So the competition will be available to all who participated in the session and others as well. So we will inform you about the date, time, and the competition review, the rules and regulations through the WhatsApp group. So again, thank you, sir, for conducting these sessions. So we are planning to do some graphic designing, robotics, and Python sessions as well in the future. So join them as well.